Normandy, July 1944, 3 weeks after D-Day. A British commando team, 12 men from No. 3 Commando, crept through darkness toward a German observation post overlooking Allied supply routes. The position housed 8 German soldiers, a radio station, and machine guns that had been harassing convoys for days. It had to be eliminated silently. Any alarm would bring reinforcements from a nearby garrison within minutes. Lieutenant Jack Churchill, Mad Jack to those who knew him, led the assault. While his men carried suppressed Sten guns and fighting knives, Churchill carried something far more unusual: a compound crossbow, modern design, strung with steel cable instead of traditional cord. In his quiver rode 8 bolts with razor-sharp broadhead tips. The team approached within 50 meters. Churchill could see the sentries silhouetted against the night sky, rifle slung over his shoulder, smoking a cigarette. Standard procedure would be creeping close enough for knife work, but that meant crossing open ground where moonlight might expose them. Churchill had a better option. He raised the crossbow, acquired the target through the weapon's rudimentary sights, controlled his breathing, and squeezed the trigger. The crossbow released with a soft thwip, no louder than a twig snapping. The bolt crossed 50 meters in under a second, struck the sentry in the chest, and punched completely through his torso. The German collapsed without a sound, cigarette still burning in his hand. Churchill's team moved forward immediately. Before the remaining Germans realized they were under attack, 3 more sentries died to crossbow bolts, silent kills that gave the Commandos crucial seconds. By the time the survivors raised the alarm, British soldiers were already inside the position. The fight was brief and savage. Within 5 minutes, the observation post was destroyed, 8 Germans were dead, and Churchill's team was withdrawing into the darkness. The radio station never transmitted an alarm, reinforcements never came. And German intelligence, examining the aftermath, found crossbow bolts embedded in wooden structures and corpses, weapons that shouldn't exist on a modern battlefield, killing soldiers who'd believed firearms made ancient weapons obsolete. This is the story of the Commando crossbow, and how British Special Forces proved that medieval technology could outperform modern guns when silence mattered more than firepower. Let's rewind to 1942.
British commandos and SOE operatives were conducting raids behind enemy lines, sabotage missions, reconnaissance operations, assassinations, where success depended on stealth. The problem was noise. Every weapon they carried made sound that could alert enemies and trigger responses that would turn stealth operations into desperate firefights. Suppressed firearms like the Welrod pistol and Delisle carbine were remarkably quiet, but still produced audible reports, enough to alert nearby sentries or trigger alarm responses. Knives were completely silent, but required extreme proximity, creating enormous risk for the attacker. What British Special Forces needed was a weapon that combined range with true silence, something that could kill at 50 to 100 meters without making noise that would compromise operations. Someone at Special Operations Executive Headquarters suggested crossbows. The initial response was skeptical. Crossbows were medieval weapons, obsolete for centuries, outclassed by firearms in every measurable way. But as planners examined the idea more carefully, crossbows' advantages for specific scenarios became apparent. A crossbow firing a bolt made almost no noise, just the mechanical sound of the limbs releasing and strings snapping forward, quieter than a cough. The bolt flew silently, no supersonic crack, no explosion, nothing to alert enemies beyond the target's immediate vicinity. And unlike suppressed firearms that degraded with use or required special ammunition, crossbows were mechanically simple, reliable, and could be manufactured with readily available materials. Station 9 took on the project, working with archery experts and mechanical engineers to develop modern crossbows optimized for military operations. They weren't recreating medieval designs. These would be 20th century weapons using contemporary materials and engineering, incorporating only the fundamental crossbow principle: a bow mounted horizontally on a stock, storing energy mechanically and releasing it to propel a projectile. The development program produced several variants between 1942 and 1944. Some were compact weapons for close-range work. Others were powerful designs capable of penetrating body armor at extended ranges. All shared one critical characteristic: they killed in near-total silence, making them invaluable tools for operations where stealth was paramount.
Creating military-grade crossbows required more sophistication than simply recreating medieval designs with modern materials. Station 9's engineers approached the project scientifically, analyzing the physics of crossbow operation and optimizing every component for maximum performance. The limbs, the flexible arms that store and release energy, were the heart of the weapon. Medieval crossbows used wooden or composite limbs with relatively low power. Station 9's designs use spring steel, the same material used in vehicle suspension systems, capable of storing enormous energy in compact form. The steel limbs were heat-treated to optimize strength and flexibility, then shaped into compound curves that distributed stress evenly during the draw cycle. Draw weight, the force required to cock the crossbow, ranged from 150 to 200 pounds in most military models. This was far beyond what most soldiers could draw by hand, necessitating mechanical cocking mechanisms. Station 9 incorporated various systems, lever cocking mechanisms that provided mechanical advantage, allowing soldiers to cock the weapon using body weight rather than arm strength alone, and stirrup systems where the shooter placed a foot in a stirrup at the crossbow's front, using leg muscles to draw the string while pulling the stock upward. The string material was critical. Medieval crossbows used natural fibers that stretched, degraded with moisture, and broke unpredictably. Station 9 used braided steel cable, similar to aircraft control cables, that didn't stretch, resisted moisture, and had predictable service life. The steel cable also transferred energy more efficiently than fiber strings, increasing bolt velocity. The trigger mechanism required precision engineering. Unlike firearm triggers that release spring-loaded firing pins, crossbow triggers had to release strings under hundreds of pounds of tension without jerking or disturbing aim. Station 9 developed trigger systems using hardened steel sears and carefully shaped engagement surfaces that released cleanly with minimal force, typically 3 to 5 pounds of trigger pull, comparable to quality rifle triggers. The stock was crafted from hardened wood or early synthetic materials, shaped to provide stable shooting platform and comfortable grip. Stocks incorporated features borrowed from military rifles: pistol grips for control, shoulder stocks for stability, and sling attachment points for carrying. Some models included folding stocks for compact transport. Sights varied by model and intended use. Close-range versions had simple iron sights, front post and rear notch, adequate for targets within 50 meters. Long-range variants incorporated more sophisticated sighting systems, including adjustable aperture sights and even primitive optical sights scavenged from damaged rifles. Effective aimed range was typically 75 to 100 meters, far shorter than rifles but adequate for stealth operations where targets were usually much closer. Bolt design was equally important. Station 9 produced bolts, the crossbow projectiles, often incorrectly called arrows, using aluminum alloy shafts tipped with various warheads. Broadhead tips, razor-sharp blades arranged in triangular or cross patterns, were standard for anti-personnel use, designed to cut through flesh and create massive bleeding. Bodkin points, narrow armor-piercing tips, could penetrate steel helmets and body armor. Some bolts incorporated explosive charges or incendiary compounds for specialized applications. Bolt length standardized at approximately 40 centimeters, longer than medieval quarrels but shorter than traditional arrows, optimized for the specific limb geometry and draw length of Station 9's designs. Fletching, the stabilizing vanes at the bolt's rear, used plastic or metal rather than feathers, providing consistent flight characteristics in rain or humidity. Penetration performance was impressive. Testing demonstrated that bolts fired from 175-pound draw-weight crossbows could penetrate 3 centimeters of pine wood at 50 meters, punch through steel helmets at close range, and completely transfix human torsos, entering the front and exiting the back at ranges under 30 meters. The wounding effects were catastrophic. Broadhead tips created wounds that bled profusely and were nearly impossible to treat in field conditions. The weapons were remarkably quiet. Measurements taken during testing showed sound levels of approximately 85 to 90 decibels at the shooter's position, comparable to a door closing firmly. At the target's position 50 meters away, the sound was barely perceptible, lost in ambient night sounds. Witnesses standing 15 meters from targets reported hearing nothing. When bolts struck, the target would simply collapse without warning. Reliability was excellent in most conditions. Unlike firearms that required ammunition, cleaning, and maintenance, crossbows were mechanically simple with few points of failure. Rain didn't affect them. Mud and dirt could be wiped away without impacting function. The main maintenance requirement was replacing steel cables when they showed wear, typically after several thousand shots, far exceeding the lifespan of suppressed firearm components. Training commandos to use crossbows effectively required teaching skills that combined elements of archery, rifle marksmanship, and stealth tactics. Special Forces training facilities in Scotland established specialized crossbow courses where operators learned to shoot, maintain, and tactically employ these unusual weapons. Basic marksmanship training emphasized fundamental shooting principles applicable to crossbows: breath control, trigger squeeze, sight alignment, follow-through. But crossbow shooting differed from firearms in critical ways. The bolt's trajectory was far more curved than bullets. A bolt fired from a 175-pound crossbow dropped approximately 2 meters over 100 meters distance. Shooters had to learn to estimate range accurately and compensate for trajectory drop. Holdover techniques, aiming high to compensate for trajectory drop at various ranges, required practice and judgment. Trainers used range estimation exercises where students judged distances to targets, then engaged them with appropriate holdover. Experience showed that effective crossbow use required more skill and judgment than suppressed firearms, but skilled operators could achieve high accuracy. Shooting positions were similar to rifle positions: prone, kneeling, standing, with adaptations for the crossbow's unique characteristics. The cocking process required special attention. Soldiers practiced cocking crossbows quickly and quietly, critical for operations where reloading under pressure was necessary. Average cocking time for trained operators was 15 to 20 seconds, far slower than firearm reloads, making crossbows poor choices for sustained firefights. Tactical employment training emphasized crossbow strengths and limitations. Instructors taught that crossbows excelled at silent elimination of sentries, guards, and isolated targets, but were unsuitable for conventional combat. Students practiced scenarios, approaching sentry posts, identifying targets, accounting for wind and range, taking the shot, and immediately transitioning to conventional weapons if stealth was compromised. Mad Jack Churchill, probably the most famous crossbow-wielding commando, became both advocate and instructor. Churchill had used longbows in pre-war archery competitions and recognized crossbows' military potential immediately. He conducted many operational missions carrying a crossbow and trained other commandos in their use. His experiences informed training doctrine and equipment refinements. Operational deployments began in 1943 across multiple theaters. Commandos conducting raids on occupied French coast used crossbows to eliminate sentries before main assaults. The silence allowed small teams to approach heavily defended positions, eliminate outer guards without alerting inner defenses, and position themselves for explosive breaches or surprise attacks. In Italy, British forces conducting mountain operations used crossbows against German sentries in elevated positions. The weapon's silence was crucial in mountains where sound carried for kilometers. Conventional suppressed firearms still produced enough noise to echo through valleys and alert distant German positions. Crossbows killed without creating acoustic signatures that would betray commando locations. Operations in Norway and Greece, where British forces supported resistance movements, incorporated crossbows extensively. Resistance fighters appreciated weapons that didn't require ammunition supply. Bolts could be recovered and reused, and skilled craftsmen could manufacture replacement bolts from local materials. This sustainability made crossbows ideal for long-term resistance operations where resupply was irregular. The most dramatic crossbow operations occurred during D-Day preparations and immediate aftermath. Commando teams infiltrating German-held territory used crossbows to eliminate observation posts, communication stations, and isolated garrisons. The Operation Dead Stick assault on Pegasus Bridge, while primarily using conventional weapons, included crossbow-armed scouts who eliminated German sentries before the main force arrived.
One documented operation involved a 4-man SAS patrol deep behind German lines, observing a strategic railway junction. When a German patrol approached their hiding position, the SAS team used crossbows to eliminate 3 sentries silently before withdrawing. The Germans never realized they were under attack. The bodies weren't discovered for hours, and no alarm was raised that might have compromised the SAS observation mission. Despite their effectiveness in specific scenarios, crossbows had significant limitations that prevented widespread adoption beyond specialized units. Weather, range constraints, and mechanical factors limited their applicability. Wind dramatically affected bolt trajectory. Even moderate crosswinds could deflect bolts enough to cause misses at 50 meters. Strong winds made accurate shooting beyond 30 meters nearly impossible. Operators learned to account for wind, but this required judgment and experience that many soldiers lacked. Rainy or foggy conditions reduced visibility enough that crossbows' already limited range became even more restrictive. Rate of fire was abysmal compared to firearms. A trained operator could fire perhaps 3 bolts per minute, one shot every 20 seconds, including cocking time. Suppressed firearms could fire dozens of rounds per minute. This meant crossbows were strictly first-shot weapons. Miss the initial shot, and you'd likely never get a second chance before enemies responded. Carrying capacity was limited. Bolts were bulky compared to bullets. A soldier might carry 8 to 12 bolts comfortably, representing 8 to 12 shots maximum. Contrast this with firearms, where magazines carried 20 to 30 rounds and soldiers carried multiple magazines. The limited ammunition meant crossbow operations had to achieve objectives with minimal shots. German responses to crossbow attacks were initially confused. Finding sentries dead with crossbow bolts was so unexpected that early incident reports attributed deaths to long-range rifle shots or unknown causes. When pattern analysis revealed British forces were using crossbows, German intelligence was skeptical. Medieval weapons on 20th century battlefields seemed absurd. Once confirmed, German countermeasures focused on increasing sentry pairing and mutual observation. Isolated sentries, vulnerable to silent elimination, were replaced with paired guards watching each other and overlapping fields of observation. This degraded crossbow effectiveness by ensuring that killing one guard would alert the other, but it also consumed German manpower, forcing them to double sentry assignments. German propaganda portrayed crossbow use as evidence of British desperation. Resorting to medieval weapons supposedly proved they lacked proper military equipment. This narrative was transparent nonsense. Britain had no shortage of firearms, but served German morale purposes by portraying enemies as primitive and defeated. After 1945, military crossbows largely disappeared from conventional arsenals. Specialized forces retained small numbers for specific operations, but firearms improvements, particularly better suppressor technology, reduced situations where crossbows offered meaningful advantages. Modern suppressed firearms could achieve nearly crossbow-level silence while maintaining superior range, rate of fire, and ammunition capacity. However, crossbow principles influenced modern weapon development in unexpected ways. Some modern firearms use delayed blowback systems that hold the action closed briefly after firing, allowing propellant gases to cool and disperse before the action opens, creating sound suppression effects similar to crossbow's silent operation. The concept of mechanically storing energy and releasing it to propel projectiles influenced research into electromagnetic railguns and other experimental systems. Special forces worldwide continued experimenting with crossbows sporadically throughout the Cold War. Vietnamese forces used crossbows during the Vietnam War, finding them effective for ambushes and silent kills in jungle environments. Soviet Spetsnaz units trained on crossbows as backup silent weapons. American special forces evaluated them for counter-terrorism scenarios where silenced shots were essential. Modern commercial crossbows, popular for hunting, are direct descendants of World War II military designs. Contemporary materials like carbon fiber and advanced polymers create lighter, more powerful crossbows than Station 9 could manufacture, but the fundamental operating principles remain unchanged. Some modern crossbows achieve draw weights exceeding 400 pounds and bolt velocities over 400 feet per second, far exceeding World War II performance. The crossbow never revolutionized modern warfare. It killed relatively few enemy soldiers, probably fewer than 100 confirmed kills across all theaters. Most commandos carried them briefly, if at all, preferring familiar firearms despite noise concerns. By any quantitative measure, the crossbow was a minor footnote in World War II's vast arsenal. But the crossbow proved something important about military technology, that newer isn't always better, that ancient principles can solve modern problems, and that weapons dismissed as obsolete might still have tactical relevance in specific scenarios. The crossbow demonstrated that silence sometimes matters more than firepower, that stealth operations require different tools than conventional combat, and that creative thinking about weapon selection can provide advantages that raw technological superiority cannot. Station 9's crossbows succeeded because they solved a specific problem, achieving silent kills at ranges beyond knife-throwing distance better than any alternative technology of the era. They didn't replace firearms any more than knives replaced rifles. They complemented conventional weapons, filling a niche where their unique characteristics provided decisive advantages. For the commandos who carried them, crossbows were tools that enabled missions conventional weapons couldn't support. Eliminating sentries without alerting nearby enemies, conducting reconnaissance without compromising positions through gunfire noise, achieving operational objectives while maintaining stealth, these capabilities justified the crossbow's limitations and awkwardness. German soldiers who died to crossbow bolts experienced deaths their training never prepared them for. They'd learned to take cover from bullets, to respond to gunfire, to fight enemies using familiar weapons. But a bolt appearing silently from darkness, striking before they heard anything, killing before they could react, this was outside their conceptual framework of modern warfare. The psychological impact of crossbow attacks on German forces was disproportionate to their actual lethality. Finding comrades dead with medieval weapons embedded in their bodies created unsettling questions. If British forces were using crossbows, what other unexpected weapons might they employ? The uncertainty contributed to the general paranoia that Special Forces operations cultivated deliberately.
Mad Jack Churchill's advocacy for crossbows, combined with his documented success using them operationally, ensured the weapons received fair evaluation despite skepticism. Churchill proved that unconventional weapons in skilled hands could achieve results that conventional approaches couldn't match. His example inspired other commandos to consider creative solutions to tactical problems rather than defaulting to standard equipment. So why did this silent British crossbow outmatch guns in stealth raids? Because silence was more valuable than firepower in operations where alerting enemies meant failure. Because Station 9 engineers recognized that medieval technology, properly modernized, could solve 20th century problems. Because Commandos needed tools that complemented rather than replaced conventional weapons, filling niches where specialized characteristics provided decisive advantages. The crossbow's whisper was quieter than any gunshot, and in warfare shadows, that whisper spoke louder than thunder. From silent crossbows to explosive chocolate to weaponized umbrellas, World War II weapons reveals how innovation and creativity won battles conventional thinking couldn't. Subscribe now for more incredible stories of the weapons that changed history by breaking all the rules.